Seconds. So my name is Eric Schuler. I work as the Quantitative and Computational Research Methodologist for the Center for Teaching, Research, and Learning. And we're going to talk today about open source statistical options for teaching and for research. I am a big proponent of open source, anything for open source, whether that's operating systems or statistics as well. So the learning outcomes will be able to identify open source statistical programs for the functionality and some of their limitations, potentially select an open source statistical software that could be implemented within a course or a research project, and then locate resources on installing and utilizing open source statistical programs. There are a whole bunch out there today, and we're only going to talk specifically about 4 major types that we have. So for the agenda, we'll talk about what are open source statistical programs, why potentially use an open source statistical program, some common myths of open source statistical software, some examples, a comparison between the 4 that we recommend, and some resources on everything from installations to getting up and running. I do ask that you please hold all questions until the end. You can put them in the chat window, but I'm not going to answer them until after you get through all the slides and the materials though. Thank you. So a couple of housekeeping things first. You're going to be on mute by default. If you have questions towards the end too, you can use the raise hand function. We can have a dialogue as well towards the end. And this forum is being recorded though too. So just want to give everyone a heads up on that. The recordings will be available on C2L's YouTube channel. And if you have any questions, if you want to get copies of the slides too, I'm happy to share that too. So let's go ahead and talk about why open source statistical programs. So open source statistical programs, software that can be freely accessed, could be changed, could be shared, you can modify it, unmodify it. It is really there for the community. There's no charges, there's no fees associated with it. So that makes it really powerful, especially for students or for research labs on a budget. And also it used to be that there really weren't that much functionality. And that's really changed in the last 25 years. So why? A big thing is expense. Commercial software is really expensive, even for student license versions. A copy of SPSS, the premium one for a student, the grad pack, can run $100 a year. Stata can also be really expensive. There's also things like how to access software, like during school, if it's commercial, especially with us being remote in the fall. How are students going to be able to access the software that they need, either for coursework or for research? And we have some options like AU apps. However, there are limitations with AU apps. Specifically, it can't work with Chrome operating system. You can import data into the system, but you cannot download the data set that's been modified, nor any results. So what are some workarounds for that? As well as after graduating too. So a lot of times we spend a lot of time in research methods and statistics courses training students on how to use the different software. If it's commercial though, what are they going to do afterwards? Are they going to have to buy their own version of the software to continue refining their skills? So it creates a little bit of a gap too. And actually marketability is a big focus too. So there's actually a discrepancy between programs that are taught by universities and those taught by employers. So there's some great research out there that kind of shows a comparison of those gaps that are in the system. So that's why I always suggest open source software. It's free. A lot of these skills are marketable, especially some of the more coding languages like R and Python. And it can be available 24/7. So whether you're first getting started out with the program, or if you're doing more advanced analyses, open source is really a good option. This is a really nice quote that I always like to kind of bring up. And the same thing can be talked about with in terms of software for statistics. It used to be, and actually we're going to go into this, so I don't want to say too much, but it's really good to kind of look forward and seeing what are the common trends within disciplines and where's the fields going with this, especially within software. So here's some common myths of open source statistics software. The one I hear a lot of is like you get what you pay for. And there's always like a lack of support, that you're just given a link and you know what, you have to figure it out yourself. And maybe that was the case 20 years ago. There used to be a product called PSPP, which is kind of the inverse of SPSS. It wasn't that great, to be very honest, but it was an attempt. There's also, I've heard instructors when I was in graduate school, like maybe it's a passing fad or it's never going to take off. There's been myths of it's not as powerful as commercial software. That again, you get what you pay for. And really only small companies that can't afford commercial use open source. There's also security issues I've heard about, as well as, well, I have Stata dataset or SAS dataset or an SPSS format dataset. And so I really need to stick with that because that's the way my data is formatted. So I'm going to go through each of these myths briefly. You get what you pay for. This can't be further from the truth these days. Things like R, Python, even JASP, Jamovi, and other softwares, they actually there's a Stack Exchange, there's actually a really active Twitter community, a community forum. So if you have questions, you can actually post it on Twitter. And I've seen tweets from some of the head individuals and head developers of RStudio, and they're answering questions on Twitter and providing resources. And if you come across an error or an issue within a package or within a specific type of analysis within like R or Python or Jamovi or JASP, you can actually go to the GitHub developer page and commit and mention an error message, and they'll work and try to figure it out. There's actually numerous blogs, tutorials, videos on how to use these specific software, specific analyses within open source. And that's a big part of the community, is it's an open, inclusive community, and they want to make sure everyone's being able to answer the questions. A lot of it's paying it forward. So I remember when I first started with R, I don't want to say how many years ago, just say it was a good amount of years, and they really wasn't all that out there because it was somewhat new. And now if you just literally Google search a question in R, like how do I run like a multidimensional IRT model in R, there's tutorials, handouts, and walkthroughs and videos on how to do this step by step. Another one, passing fads. R actually just celebrated its 25th anniversary, and Python was released in 1991, just to get some perspective. They've been here for a long time. They're not going anywhere. Unlike POGs, which admittedly I used to have a POG collection. JASP and Jamovi, those are two also some newer open source statistical programs, but there's already schools actually using them as replacements to SPSS. One of my friends who's an assistant professor over at a small liberal arts college, their school decided they looked at the cost of SPSS and they switched over to JASP and haven't looked back. And I've heard nothing but good things of it. There's issues of, well, open source software, it's not going to be as powerful as commercial. And actually, this is a common myth. Unlike commercial software, development in open source happens overnight a lot of times. So if there's a need, there's individuals working on that, trying to fill that need, whether they're making their own R packages or Python modules or macros for other software to fit their need. And then because they've developed it, they share it with others. And this can actually be put on some direct repositories. So if there's an issue or a problem or a gap, there's probably individuals working around that trying to figure out how to correct for it. There's actually over 20,000 R packages to add additional functionality in different types of analyses. Everything from, there's change point analysis, sentiment analysis and topic modeling, to structural equation modeling, multi-level modeling, item response theory, visuals, dashboards, shiny applications for websites. It's extremely robust. And actually R and Python, there used to be a huge debate on, are you an R user, or are you a Python user, and the pros and cons of each one. Actually nowadays you can actually integrate the two to work together. So that's a really nice feature. And also, hate to break it to you, if you're using SPSS or Stata, they come with Python integration. And actually, SPSS actually has Python as part of the installer by default. They can choose not to install with it. So even commercial software is somewhat using open source Python or R integration more and more these days too. So only small companies use open source. Actually, a lot of times more and more companies are relying on open source because it's more powerful, it's free, keeps the overhead down. So there's actually a growing demand for these programming languages. Data science actually primarily depends these days on R and Python, as well as Julia. Julia's somewhat new. It's, I want to say, like 8 or 10 years old now, but it's starting to kind of develop more and more. There's benefits to Julia, but we're not going to talk about it. It's inherently multi-threaded. So if you use R or Python, a lot of times it's like a single thread. So this actually inherently parallelizes. So it's really powerful, but it's not as well developed yet. So here's some companies that actually use R and Python and actually look for people who are doing analytics and data analyses. This is what they're kind of looking for in their languages. So we have Python, Netflix. If you ever used a Netflix recommender system, so it's like, hey, you watch this, here's what we think you might enjoy. That's actually running a Python recommender system in the background. There's things like Twitter, Airbnb, Uber, and Microsoft. And even though Microsoft is commercial, they actually use a lot of open source products too for development. Some things like Uber and Google, they've actually been really helpful in terms of deep learning models and TensorFlow. So there's some phenomenal stuff out there. Security issues. This is also a really common myth too for open source. My apologies, that image is really, really pixelated. There's been a lot of issues and voiced concerns about security issues. Like, you get what you pay for, and there's going to be malicious code because it's open source. Official packages with R and Python are actually screened for malicious code before they're made publicly available. So that's really a good feature. They don't check the mathematical proofs though. So that one you might want to do, some comparisons within it. But you could also use R and Python that's not connected with GitHub. There's certain organizations in downtown DC that used to not allow for anything open source, and that's actually drastically changed. The place I used to work at, we couldn't use R or Python, and then that was actually approved, and you could actually use R or Python, but you just couldn't use RStudio or things that connected with GitHub for security reasons. Especially within both communities of R and Python, security is a critical concern for all sorts of data science. So that's actually always on their minds. And then finally, you won't be able to use MyStata or SAS or SPSS formatted data. And the things like a stat transfer, those are kind of fallen by the wayside because a lot of programs can actually inherently import different types of data files. So let's say you have a fully developed and formatted SPSS dataset or a Stata dataset, maybe even a SAS data type. You can actually read those directly into R and into Python, as well as directly into Jamovi and JASP. They can automatically read that and save that formatting. So there's actually numerous functions to be able to convert and manipulate data. So really, if you have data that's formatted in another system, it's really not a problem at all these days. I also want to mention a little bit of some trends of statistical programming. So there is kind of a relative proportions for searches are fairly consistently high. It does have a JASP, but Jamovi's a little bit newer, so we don't really see that. But we can start seeing the scholarly citations for SPSS, it's drastically reducing. So we're going to talk about 4 specific software today. We're going to talk about R, we're going to talk about Python, JASP, and Jamovi. JASP is actually standing for just another statistical program. So before we begin, I want to give a little bit of a comparison. And we're going to go into a little bit more detail with each one of these. And depending on how you're using statistical software and what the resources that either you or your students have, what you're trying to do, that's going to really determine what one you might want to consider. So like I mentioned before, AU apps cannot run, or cannot work with Chrome OS systems. That's just a known issue. So some workarounds. If you are soon using Chrome or Chrome OS, you can use it with RStudio, Python, or Jamovi. JASP, or just another statistical program, it doesn't work with Chrome OS either. For interfaces, if you're looking more like a syntax or command line, really Python or R are going to be your best bets. Whereas if you're looking for more like a point and click option like SPSS, Jamovi is a great option and JASP is another great option. It's essentially like a spreadsheet and it has an SPSS-like interface to it. For data cleaning, all of these are good except for JASP. The makers of JASP actually made sure that theirs They because Excel is so powerful for data cleaning, they actually recommend cleaning your data in Excel and creating variables there first before importing it. So it does have some really limited data cleaning options. You can do some basic data transformations and create scales, but again, it's really, really limited. Whereas R, Python, those are really robust for data cleaning. Jamovi's pretty strong, but all three are really good for data transformations and creating new variables. If you're looking for univariate tests, all these are great options. Multivariate, R and Python, they're going to be your go-to. If you're looking for more like EFA, factor analysis, Mancova, or MANOVA, Jamovi and JASP have some options. If you're doing structural equation modeling or latent variable analysis, you're probably going to stick with R or Python. JASP and Jamovi have some options for some basic CFAs, but it actually uses the R code for that. Multi-level modeling, these are all good. If you're using machine learning, and this is actually quite interesting, Python and R are known for machine learning. JASP actually has a built-in module that you can add to it that's free, and it has a lot of different machine learning algorithms too. Jamovi doesn't have that yet. And if you're doing time series, unfortunately, JASP and Jamovi, those won't be the options that you want to use. So that's kind of just a little bit of a comparison. So really, it depends on your focus and your needs. So a little bit about Python. Python is a general purpose language. It can do visualizations, websites, so dashboards. It's also really known for data science and statistics, especially if you're doing anything with deep learning, artificial intelligence. Python has some really good features. It is an object-oriented language. So anything is an object. If you have a data frame or a data set, that is an object. If you have a list of variable names, that can be an object. An object can also be the results from a regression analysis, or it could be just a grouping variable. The syntax is actually quite easy to pick up. So it is, since it is an object-oriented language, pretty consistent. It's just kind of you want to make sure if you're using tabs with it and so forth. But some common applications, you see a lot with it being talked about in machine learning, TensorFlow, deep learning. And if you're doing things like natural language processing, like topic modeling, sentiment analysis, Python is a fantastic tool for that. A little bit of, I'm always going to be honest with you all about this. There are some cons with each of these. One con within Python is package updates or module updates can be a bit of a nightmare for dependencies. If you try to update one manually, you might have to go through that process and reconfigure everything. The nice thing though with Python is there's a distribution called Anaconda, and that will install a lot of the most commonly used modules. So that's really a good way to get up and running. That way you're not having to download each and everything separately. The next one, and I'll be very honest, this is my personal favorite, and one I use personally a lot, is R. It's started off as a really versatile statistical programming language, and now it's becoming more and more general. So you can actually do things like some website design. You can do some like interactive dashboards. There's things like it's different softwares within the packages, like time series, multidimensional scaling, IRT, a whole wide range of different statistics, as well as GIS. It can do some different spatial statistics. It can use rasters. So it's really, really versatile. And it's really community driven. Again, over 2,000 R packages that really increase the versatility and the breadth of R functions. And the inclusive community. There's hashtag RStats. They're fantastic. There's also, let me go ahead and open some of these up. A big proponent of the inclusive community for R is We Are R Ladies. Each week they have a different data curator on their Twitter handle, and they walk through some great tutorials, recommendations, tips, suggestions for using R and their experiences. They have a directory, and they actually have a link to their entire GitHub page where they have everything available too. Their different meetups, just a really, really fantastic community. There's also R for data science. There is a completely online book by Hadley Wickham, one of the head honchos over at R Studio, and Garrett. And their entire book is also always going to be free online. And there's actually an R community that each week they go through different chapters of it. So it's really kind of a really nice online community to just go through the book too to learn R. So R in RStudio, same functionality as Python. R base R, it's not that great to program with. However, RStudio, this is kind of this interface. It's really similar to the Spider interface. And Spider and RStudio, they're different IDEs, or essentially different interfaces to work with those programming languages. R is also an object-oriented one. So you can create interactive web pages. You can actually create formatted reports, books, blogs. And there's actually an increase in R being taught at AU. The data science center is using R as well a lot. There's also many, many free resources on getting started, and I'm going to circle back to that in a little bit. So this is actually using an image classification. So I'm actually using TensorFlow in the background. So I've ported R to link up with TensorFlow and use an image recognition algorithm. And it's not that great actually with this one that I ran. So some cons though, there is a big learning curve for the syntax. It takes time, but once you've learned it, it makes learning all the other different statistical programming languages fairly easy. And actually when teaching R, the biggest role I've seen is working with working directories and getting that set up. So that's the biggest hurdle I've seen for teaching with R. Switching gears, we have JASP, or Just Another Statistical Program. It's an SPSS like R interface, so you actually don't have to download R at all. It is a point-and-click interface, so like if you use the SPSS, it's that same idea. And the nice thing is the output is an APA format. So it gives you APA formatted figures and tables, and it's really easy to copy and paste that into Word. And it contains a majority of the different tools that you would maybe teach with an undergraduate research methods course or statistics course. This is kind of an example of what it looks like. So it has that kind of that spreadsheet feel and uses the same image types for the variable types as SPSS. It has that nice kind of variable drag and drop like SPSS. And then it creates all the different results in the same tabs. And the one thing I do want to mention is it's actually written in C++ and R, a combination of those two. And there's no kind of plugin working with R code directly. So that is a limitation with it. The nice thing is actually on their website, they even say if they turn evil, it will still always be free. So you can get a sense of how they feel about that. The con is it's not great for data cleaning. If you're working with or having students work with really messy data, they really need to spend time in like an Excel sheet and really clean that first. There are some Bayesian analysis too. So actually JASP is a combination of frequentist, null hypothetical testing, as well as Bayesian. But the Bayesian, they're not as robust as our Python. So it's a lot of the default priors. Jamovi. This is a fantastic, fantastic program. I didn't start playing around with it until like a year ago. I used to be more of a JASP fan, but Jamovi, I've been really sold on it. It's really similar to JASP. It's considered a third generation statistical spreadsheet, and it's designed to work as a spreadsheet and also gives formatted output tables. This is kind of what the interface looks like. So it's really similar to JASP, but you can actually have R scripts. So if you work with R or you work with someone who has R, they can actually write flexible R code and macros and add that to give Jamovi more flexibility within this. The development's really fast. They've actually recently added a whole series on some tools to do meta-analyses within Jamovi, as well as some really nice psychometric properties too. It's always going to be free. However, just like JASP, it can't do web scraping and it can't do text mining. So if you're really doing like topic modeling, sentiment analysis, web scraping, these aren't going to be the tools for you. You'd really want to use R or Python. Again, Bayesian analysis, there's an add-on to this as well. We can do classical tests, which is null hypothetical tests, or Bayesian. Even though Bayesian is actually older than null hypothetical tests, that's going off on a tangent a little bit. But the Bayesian analyses are okay. It's a lot of the default priors, so it's again not going to be as robust. So I want to talk a little bit about some open source analogs. And then later on, I'm actually going to see like, if there's a specific software you want me to kind of show or demo, I can switch gears and do that too. So if you're using SPSS for research or for your own classes, I consider maybe Jamovi or JASP. There's also an add-on called R Commander, and that works as like a little pop-up interface interactive GUI, almost like SPSS. You can kind of point and click through. It's really basic, but it's a good way to kind of start getting familiar with R code. If you're using something like Stata, then you probably want to consider switching over to R or Python, and same thing with SAS. So CTRL workshop materials. We use public-facing data sets or heuristics and create example codes. So all the codes handouts are available to anyone, and always encourage individuals to take that data and try different things with it, try some different types of analyses, explore and get the feel for the software. So all the workshop materials that we have are going to be under Creative Commons licenses. So that's going to be at the bottom of each of the different handout. Because we believe in open science and open coding, we want people to be able to learn from this, adapt it, and really pay it forward. So I do want to mention, these are some of our new workshop materials. So over the summer, I've been working to create and modify these. So we have our R&R Studio and our Python ones from previous semesters that's been kind of just changed up a little bit, as well as we now have workshop materials for JASP and workshop materials for Jamovi. And they're all using the same data set, and they walk through all the same type of analyses. That way it's kind of the same approach whether you're trying to learn both these at the same time through comparisons. So coming soon to a CTR website near you, I'm really excited about this. We're going to be doing and having an on-demand software workshop material series. So as the fall semester is about to start, we're updating our website, and I've created a video series for each software that walks through basics like how to connect or how to install a program, importing data, doing some data cleaning, some analyses. So all of those links to our YouTube channel. And these videos have already been posted to our YouTube channel, so they're already available. We're just making the website and adding everything in there though, so that's gonna take a little bit of time. But each link is about 10 to 20-minute video with example code, data, and walkthrough that's gonna link you to a Google Drive. So we have the R, the Python, Jamovi, and JASP already uploaded. And we're probably trying to create some additional PDFs or resources, specifically within R as well. So this way, if you want to include materials on getting started with SPSS for your course, we want to be able to have your students and have you be able to have access 24/7 to these, as well as be able to kind of rewatch things. So we're really pushing for these recorded videos. That way, they're just going to be purely on demand at any point. So a lot of times it might just be a flood of information if it's a one-time introduction. So this they can go back to and rewatch it over and over again. So if you're using open source in your class, a couple of suggestions. Maybe having in your syllabus an instructional technologies discussion part, and mention a little bit about what software they'll be using. And if it's open source, this is when I wrote up for statistical simulations, and providing the link for both R and RStudio. That way they can go ahead and download it. There's also programming books too. So there's an agreement with O'Reilly Books in the library, from my understanding, as one of the databases. And you can actually have access to all the O'Reilly books on demand. So you can read through, they have some really great ones on learning Python or learning R or machine learning or text analysis or web scraping. So they're all there, and with the library you just had to create an O'Reilly account, and they can actually download an app on your mobile device too. So it's a fantastic resource. There's also a CRC Press. They're a big proponent of creating some different statistics and some different software books. And there's actually a common trend now within CRC Press where you can actually have the books be public facing. So there'll be a website for it and online completely too, which is really, really good trend. These are some examples too of some different books. There's if you're doing a spatial temporal statistics, space-time with R, R for data science, we already talked about, advanced R. And if you go to the book down, these are all specifically within, because these are actually written in R completely. So there's something called R Markdown, which allows you to essentially write all your text, import to the code, and when you compile it, it gives you an HTML page or a PDF. So all these actually all written in R using R. So there's a whole bunch of different materials, and these are all free. And actually some new ones in here too, which I'll have to check out. So where to download? If you're really interested in these, there's for Jamovi, It's jamovi.org. JASP is just jasp-stats.org. For R, you actually have to download from two different sites. One of them is for the base R, and then the RStudio IDE to work with R. And if you're doing Python, I highly recommend the Anaconda distribution. It is fairly large, but it downloads all different toolboxes and modules that you'll need to get up and running with it. So I figure we can kind of shift gears. I want to have some time for questions, and then if you're all interested in me kind of walking through one of the softwares, I'm happy to do that too. So if there's any questions, you can go ahead and raise your hands or put it in the chat box too. And if there's, and if you're really interested in one of these four to kind of walk through, let me know and I'll go ahead and pull that up and we can go from there. So I see a question about how to access the CTRL workshop materials. So we're still in the process of updating our website, so that's not available yet. But in the next week or two, that will be posted on our website. And that's going to be, there'll be a little bit of announcement on that under the research information. Good question. So there's also a question about recommendation whether R or Python better for text mining and analyses. So for that, it really depends. If you already know R, if you already know Python language, either of those are fine. It really depends on what you're trying to do. They both have their benefits within it. Some people swear by Python more so than R. It really depends on either one of them. So it's really personal preference. Python is a little bit easier to get up and running with compared to R. However, they're both really powerful for text mining specifically. You can also web scrape as well. So if you're trying to web scrape the text and then do that, that's also an option too. So I also see a comment about Jasper Jamovi. So I can go ahead and open both of those up to kind of see what they look like. And I can kind of walk through a little bit if that sounds good. Does anyone have a preference between Jasper Jamovi? Okay, so I see a couple of people interested in Jamovi. So let's go ahead and we'll open up Jamovi. So let me go ahead and get that started. So this is what Jamovi looks like essentially when you first open it up. It's going to go ahead and have A, B, and C by default. And I'm going to go ahead and there's two main tabs. There's a data tab and an analysis tab. So whenever you open up the data, you want to click on the sandwich icon, and then you can go ahead and click on import. So let's see, I'm going to go ahead and just going to browse through and open up one of the data sets we have. Oops, nope, not MATLAB. Let's say we have an SPSS data set. I'm going to go ahead and directly import the SPSS data set we commonly use right into Jamovi. Now it's already imported it, and I just need to remove these first three variables just because those are kind of just placeholders, and I can go ahead and delete that. Let me go ahead and move this over a little bit. So we have our different variables. It already, because the SPSS was formatted with a variable label or value labels, like OECD member, whether or not they're a member, it's coded as, if I double click on it, this is kind of similar to SPSS in that the variable view icon. So you can change the variable types. And right now it's actually saying what the levels are, whether they're an OECD member or not an OECD member. And you kind of go and shift through. So because this is already formatted SPSS dataset, it's going to maintain that formatting. If there's any missing values, it's just going to be essentially blank. And you can also go ahead and make some changes to it. Now, creating a new variable or reverse coding one's extremely easy in Jamovi too. So what we can do is I can click on the variable corrupt, which is actually reverse coded. So higher scores on this actually mean less perceived corruption. I can go ahead and click on transform. It's going to create a new variable. And I can just go ahead and call this corrupt R. I can add a variable description just like SPSS, reverse coded corruption scores. The source variable, that's what we're using for the transformation. And then using transformation, you can actually go ahead and I'm going to click on create a new transformation. And I can go ahead and take and write in the code for it. So it'll be 10 minus source or $source. So it's taking for each country what their corruption was. They're taking 10 and then minusing their corruption score from that. And I can call this reverse corrupt. And I was giving that transformation as a name. Click on the arrow down button, click on up, and now we actually have our reverse coded. You can also do things like discretize or continuous variables. If you want high, medium, low groups, you can also use that transform icon. And then do things like create a new transformation. You can add conditions using if-else statements too. So there's things like the setups, which is kind of just that same window we had. There's multiple ways to get to the same points within Jamovi. The nice thing too is you can also create filters. So if you wanted to filter your data, it's really easy to do too. For analyses, I'm going to go ahead and remove some of the modules I have. Actually, I'll maybe hold off on that. I've added a bunch of things to this. By default, it comes with exploration, t-test, ANOVA, regression, frequencies. And if you click on the modules, you can actually install from the Jamovi library. So if you wanted to do power analysis, if you wanted our editor, so you can actually go through and add additional types of plugins to make Jamovi even more powerful. I was actually already installed all of these. The psychometrics one, it's pretty good. The Bayesian method's pretty good. If you're doing advanced mediation, like multiple mediators or conditional mediation, similar to the process model, this is a nice feature as well. If you're doing general analyses for limited models or mixed models, there's also a function for that too. So we can go ahead and if you click on exploration and go to descriptives, you can go ahead and just drag this over. Just like SPSS, let's say I wanted to get corruption scores. And then if I wanted to split this by a categorical variable, like split whether or not they're an OECD member, I can go ahead and do that and it will say, okay, whether or not they're a member for the grouping for OECD, the counts, how much is missing, the mean, median, minimum, maximum, also the references. You can also get frequency tables if you want by just checking the box. I'll go ahead and hold off on that. We can also do things like get some more information like standard deviation, variance, skewness and kurtosis. And it just goes ahead and, because it's a dynamic output, it's going to go ahead and update that for you. There's also some different plots you can do too, like box plots, histograms. So I'm seeing a question about generating a log file. So actually what you can do is, there's no like syntax here. Like you can do an R syntax plugin, but there's no like SPSS syntax. But what you can do, let me go ahead and grab these. And so it's updating right now. So we have our plots. If you wanted to export this, we can export it out, we can duplicate it, we can copy it. You can do that either at the analysis or at the all option. What we can also do is I'm going to go ahead and click on save. And I'm going to call this on my desktop Untitled Project, which is a horrible, horrible file name. So not good for data management, just as an example. I'm going to go ahead and close Jamovi. And I didn't save any output, I didn't export it though. But let me go ahead and move some windows around really quick. So where is my project? Oh, there we go. So I'm going to go ahead and double click on my project. That's going to restart Jamovi. And it's all there where we left off too. So we can actually go in and we can kind of save everything within the project as we run it. So it does kind of inherently keep all that information as long as you save the project. So that was a very good question about the logs. We can go ahead and let's say we wanted to run a regression. And let's say just a simple linear regression. I can go ahead and put my corruption 2 as a covariate. So it's just going to be essentially the same thing as SPSS. We can add in any sort of factor variables or ordinal into there as well. And I'll put GDPP there. Oops, let me click back here. And they'll print out the basic model. Then you can go ahead and you can add more information to it as well. Some different plots, some different statistics, and so forth. And if you want to go ahead and remove something too, you can go ahead and click on, let's say after running this, I'm like, you know what, I don't like how that turned out, or maybe I put in the wrong variable and I should have transformed it. You just click on remove, and that removes it from the project. So it does kind of keep it all nice within this. You have your data and results all within a project too. Great questions. Let's see, so for ANOVAs, it does have standard ANOVAs as well as non-parametrics built in. And because we have the Bayesian component, it does have that Bayesian option too for ANOVAs, t-tests, and regressions. There's also things like reliability analysis. So you're doing scale scores and you want Cronbach's alpha or KR21s. You can do that. If you're doing data reduction techniques from multivariate statistics, like principal component analysis or exploratory factor, you can go ahead and do the same thing. It's just like SPSS in there too. And the nice thing is built into it, it can do based on parallel analysis, which is one of the gold standards for determining how many factors to retain. So that's built in directly rather than based on eigenvalues. So you can change the rotations, you can do the extracting methods, and get all the information there too. If you're doing more of a confirmatory factor analysis, moving over to SEM, now it can only currently do factor analysis as like a confirmatory factor analysis, not full structural regression models. But it's going to be really similar to, you can just drag your, I mean, it doesn't make sense within this data set. We go ahead and create our latent variable, and you just go ahead and drag in the indicators. And they can go ahead and put in the different options, the different estimates. You get model fit statistics, so as all the common ones, as well as AIC, BIC, and additional output. And it all comes out as a really nice formatted table. If I go back to our descriptive statistics, I can go ahead and right click, and let's say I just wanted the table. I can just copy directly that table. I can, oh, I guess here's a little bit of a sneak peek. This is the additions to our website that I'm going to be adding to. So we have the materials and all the video links. So again, that's going to be a work in progress, but hoping to have that up in the next week or two. You can just go ahead and copy and paste that and then change some of the formats, and then you're good to go. So it makes it really easy to then port all that information back and forth. Great. Any other questions about Jamovi by chance? Do you want me to open up JASP to kind of give that as a comparison? Okay, so I'm gonna go ahead and actually I'm gonna use the same exact data set. That way you can kind of see a comparison within this. So I'm gonna go ahead and launch JASP. And if you go to like Association for Psychological Sciences, or APA. The JASP folks are always there, and they have some pretty good swag too. So it's always going to be free because it's actually funded by a grant from the University of Amsterdam. It's going to be kind of that same idea. So I'm going to go ahead and open, and I'm going to go find that data set. I don't want to use the Adam Sandler one. It has some really interesting default ones in there. So we go ahead and go to the SPSS, and I'll import that in. So it's going to be the same idea as just like an SPSS spreadsheet. I've went ahead and I've customized it a lot. So let me go ahead and uncheck these customization ones I've already done. So this is basic JASP. If you wanted to make edits to the data set, there's two things you can do. You can go either directly back into the data set, like an Excel, and open up it that way. There's also a feature where you can do sync data. And if you already have SPSS installed, or if you're using this as an Excel file, you can open up the sync data, and that's going to go ahead and open it up in that specific package to make alterations, because again, you can't really data clean too much within JASP. But this allows you to sync simultaneously, and then it'll update JSP automatically. So if you already have a project created here and you're like, oh no, I forgot to recode this, you can go ahead and sync it and update it on the fly. Like for this one, we didn't do corrupt, so I can go ahead and I could do that same thing. I just don't want to open up SPSS for this, but essentially it'd be the same idea. Let me go back to, oops, clicked on the wrong thing. So to get back to the data, you can go ahead and click on this arrow on the side, and that's going to move that tab over. So it's essentially you have one part of the screen is going to be your data, the other one's going to be any sort of analysis that you're running. We drag that one back over. So we have our countries of interest, we have our OECD members, and if we click on that, it's going to go ahead and tell you the variable, what's a 0, what's a 1. The nice thing with JASP is if you wanted to filter and do an analysis just on if they're an OECD member, you can uncheck that and it's going to filter out your data for you automatically. And then just to go ahead and fix that, you go ahead and easily just recheck it. For descriptives, it's just like that SPSS field. Let me go ahead and get rid of these other ones because I clicked through. And so let's say I wanted corruption by OECD membership. It's going to be the same thing as Jamovi. It also has some options, some customizable plots. So you can do box plots within that to see the spread outness of corruption scores based on OECD membership. We can do like label outliers, and I'll go ahead and add those to it. We can also do things like for under statistics. We can ask for some more information. Let's say one of the variants. I want the median, mean, and mode. And it's going to some kurtosis. And it's dynamic, so it automatically updates for you. The nice thing within this is we can actually rename this. So let's say you're doing descriptive statistics, but we want to rename the column for it. So you can click on this little pen-looking thing, and that allows you to enter the title in, and that's going to automatically update your output too. So you can actually edit, you can duplicate, you can copy, you can add notes to it as well. So if you wanted to use things like an SPSS where you had like a syntax file and you annotate it, you can go ahead and start like this analysis, and you can add to it. And then that's going to import it so you can actually, if you change this to a PDF, it will go ahead and have all that within the PDF document or within the Word document. You can also add to it if you want to make a copy of it. And then that way you don't have to change all the features and you just want to swap out workgroup or swap out the variable. That's an easy fix. There's also, if you click on the I button, that's going to pull up all the information for the descriptives. It gives you a little bit of a nice thing of what everything means within it, as well as for the output, the tables, correlations. It all includes citations as well too, of the methodologies that they're using. And in the output, if we scroll down, we can actually add the citations too. And it also tells you if it's using any R packages, because it has like a light version of R embedded, what it's using there specifically. So we go ahead and click here. I can copy citations. Now it's copied to the clipboard. We can also copy any results. So let's say I just wanted this descriptive table. I can click on this arrow button and I can copy. You can also copy it to LaTeX as well. So you can go ahead and copy it and then, oops, that's the wrong one. I can just go ahead and paste it. And it's really, really easy to paste these too. And it has a little note that corresponds with it. You can always make those changes too here. So that's a really nice feature. Let's say you wanted to run a t-test. It's always going to have the classical or null hypothetical tests, as well as all the corresponding Bayesian. And that's true for t-tests, ANOVAs, mixed models, as well as going to use Bayesian mixed models, regression. For the frequencies, it has both binomial, multinomial, contingency tables, as well as the Bayesian counterparts. And for factor analysis, it has physical components analysis, exploratory, and confirmatory. And actually, they've updated this. It used to be you had to type in all the Lavaan code. So this is a nice feature. So you can go ahead and do the same thing we did in Jamovi and build a latent variable. It's going to, and you can also say, well, maybe you're doing second order modeling, where you have this higher order version of, let's say we have a facets of intelligence, and there's a general intelligence latent variable. Second order factors are really easy with this. You can do measurement and variance and do testing based on configure and all the different options there too. They have plots for misfit in the models. We haven't created a model yet, so it's not going to work. But this is actually quite robust, and you can select what estimators too within this. And if you wanted to emulate like an M+, so if you use M+ typically for latent variables, you can have it emulate that and use that algorithm instead. And everything you just copy and paste it out. The real benefit though is the modules. So let's say you wanted to do, if you're doing Bayesian with JAGs, they have a JAGs option. If you're doing meta-analysis or machine learning. So we go ahead and select a bunch of these and the R pass-through too. So if you're using machine learning, it has regression, classification, and cluster analyses. If you're doing meta-analysis, you can either do classical or Bayesian meta-analysis. Reliability for single tests or for scales. For SEM, if we click on that, this is actually going to be using the Lavaan R package. So you will have to learn a little bit of the Lavaan language, but there's fantastic tutorials on R that walk you through step by step. And if you know R, but your students don't, you can actually give them R code and you can cut and paste it here and run it here as well. So it's R within JASP, which is a really nice feature. So both of these are really powerful and they allow you the Bayesian options. But I really like the being able to copy paste directly into a Word and have it be close to APA formatting. And then being able to edit and kind of have your results section with your data all within one project file. So you don't have to have it like in separate ones like SPSS. We have an output file, a syntax file, and a data file. It's all contained in one project. So that's a really nice feature. Great. Any questions about JASP? Or maybe just any questions in general? I see a question about OpenRefine. Unfortunately, I can't comment that. I haven't used OpenRefine. So typically for, let's see, for data cleaning, if you have access to Excel, that's what I've done some of the data cleaning in the example for the workshop. Just because AU does have that, for all students can download a copy of the Microsoft Office suite. I'm not quite sure about OpenRefine though. I'd have to play around with that. That's unfortunately not one I'm familiar with though. But potentially that might be an option. I was in with the formatting types for input datas. Let's see. browse. Let me see what the file types it can be. So it can be all these different types of data set you can read inherently. So as long as it's within that data file type, if you're using OpenRefine to make edits to your data set for data cleaning, you can definitely do that. The nice thing too, I didn't mention this, JSP can be built-in integration with the Open Science framework. So that's a really, really fantastic feature. And they also have, if you're trying to learn some different types of analyses, they have different books and some information on it. So if you're using Andy Field's book, it has all of Andy Field's fictional data, and you can walk through and have that information in there. So we go ahead and move this over, and it's actually opened up a separate JASP tab, and it's built in. It has all the information from Andy Field's book for the specific analysis, the example, so you can kind of see how it's set up. So they've actually taken Andy Field's book on maybe, I think this is Discovering Statistics Using SPSS, and modified it to work in JASP for all the language too. So that I did not know they had that. So it's actually really cool to find. Good, good question about data cleaning. That's my one drawback with JASP is just it's not an integrated system for data cleaning. That's my hesitation with it. Otherwise, it's really great. Let's see, other questions by chance? What do you all think about this? Could you imagine maybe using an open source one or even your own research or maybe in the classroom? Okay, so I see a checkbox says yes, great. That's good to hear. And again, in the next week or two, we'll have that website up and running with all the different handouts. I also have some of them, because I'm still actually recording one or two of the series left. So happy to share those if you want just the YouTube videos or some links to that until it's being developed. I can share those, but do recommend the website checking back in there too, because that's going to be the central repository for everything that we're going to have. Well, that's pretty much all I have prepared. But if there's other questions, I'm going to stay on for like another 15 or so minutes. And also, if you'd like to, rather than using the chat window, if you'd like to go ahead and unmute yourself, we can also discuss too. So always happy to kind of discuss these. Just let me know. Let's see. I see a question about results for ANOVA. It's going to be varying depending on programs. I haven't done any side-by-side comparisons. The results I've seen within like SPSS, JASP, Jamovi, they've been really close. So I mean, usually there'll be slight variations within for the rounding for the decimals, but they've been pretty close to one another. You can actually run this with the workshop materials if you want to do the kind of side-by-side comparison. But we actually within JASP, Jamovi, we run both of those within a one-way ANOVA. So those are definitely options within it. The nice thing too within the classical ANOVA is it offers the corrections too. So for the model assumptions, the homogeneity test, and then the different corrections as well. So it offers you the standard, the Welch test, as well as the Brown-Forsyth option, as well as built-in post-hoc comparisons. If you have a priori contrast, there's there too, as well as main effects, marginal effects, and so forth. So if, let's see, for the two of those, they'll be pretty similar to one another. Um, for R, I haven't done any direct comparisons. I could run them and see any drastic differences within there. So it'd be kind of something just to have to go through and try out. Great question. If you're deciding to use something more like Python or R, and you're concerned about the language within it in terms of learning it, it is an uphill to learn those. However, it's worth it too, though. It gives more flexibility than just some of the point-click options. It gives, like, for data management or data cleaning, for subsetting, R and Python are fantastic for those. Um, but there is a little bit of that learning curve. The big thing is maybe if you decide to use those, kind of starting off small and kind of giving some canned examples in code and kind of walking through and showing how to tailor the code, and then ask them to kind of replicate with maybe a different variable, or kind of to like recode a different variable, and then kind of build on that and do more like a scaffolding approach for learning them. I've seen that's been really helpful in the past. There's also the big things with using packages, walking through that, and like kind of using the library analogy, where it's like for R, you download it once, you're taking the book out of the library, but once you have it, you can just go through it at any time and read through it. But the big thing is working directories. There's also something called R Cloud for RStudio, where it's actually like it's mostly used for teaching R. I haven't personally tried it. This was released maybe a year ago. When it was released, it was really kind of, it needed to be developed a little bit more. But from what I've heard, they've made some advancements with it. But then they have to connect to a server. Whereas with RStudio, if they just do a local installation, once they're familiarized with it, it's it it's really powerful. Sort of curiosity, anyone currently using any open source statistics programs within your courses right now? Okay, good. See a couple comments, not currently, but considering it, that's fantastic. And again, if any of those workshop materials, once we have them posted, if those are helpful, by all means, feel free to share them. You can if you want to embed those links to those within your courses, like on Canvas or Blackboard, by all means, go for it. Or if you want to direct your students for it, that's great too. And all our work materials, they're all common, all Creative Commons. So if you want to adapt them to work specifically within your class or some different examples, by all means, have fun with it. So the big thing is just making these be able to be good use or good resources for everyone. So by all means, update if you want. Great. Well, this is all I have, and I'm not seeing any additional comments, but I'm going to stick around for like another 10 minutes. Um, and we can go ahead and probably stop the recording potentially. So if anyone wants to unmute themselves and have questions as well, we can do that.